How can you configure Azure Storage services to automatically scale based on workload demands? Azure Storage services are automatically scalable, meaning they can handle increased workload demands without manual intervention. As your data grows, Azure Storage automatically scales resources to accommodate the load. Explain the differences between hot, cool, and archive access tiers in Azure Blob Storage. The hot access tier is for frequently accessed data. The cool access tier is for infrequently accessed data, and the archive access tier is for long-term archival data. Each tier offers different cost structures based on usage patterns. How can you monitor and optimize costs for Azure Blob Storage resources using Azure Cost Management? Azure Cost Management provides insights into your resource usage and helps you identify cost-saving opportunities. You can analyze storage usage patterns and make informed decisions to optimize costs. Explain how to implement granular access control for Azure Queue Storage using Shared Access Signatures (SAS). You can generate a Shared Access Signature (SAS) token for a specific queue and specify permissions, constraints, and an expiry time. This token grants limited and time-bound access to the queue, allowing fine-grained control over access. How can you implement data archiving and retention policies for data stored in Azure Table Storage? You can use Azure Table Storage's features like Time to Live (TTL) and table service properties to implement data retention and archiving policies. By setting TTL values, how can you ensure data durability and availability in Azure Blob Storage during a regional outage using Zone Redundant Storage (ZRS)? Zone Redundant Storage (ZRS) replicates data across availability zones within a region. In case of a regional outage, the data remains accessible from the replicated copy in another availability zone, ensuring continuity. Explain how Azure Blob Storage's Blob type can be used for scenarios involving efficient upload and storage of backups. Blobs are suitable for efficiently uploading and storing backups. You can upload backup files in smaller blocks and assemble them into a complete blob, enabling efficient transfer and storage of large backup data. How can you manage data retention and compliance for logs and audit trails using Azure Blob Storage? You can use Azure Blob Storage's lifecycle management policies to set retention rules for log and audit trail data. By transitioning data to the cool or archive tiers and defining retention periods, you can ensure compliance with data retention requirements. Explain how Azure Blob Storage's Soft Delete for Blobs feature provides a safety net against accidental deletions. Soft Delete for Blobs retains deleted blobs for a specified retention period, allowing you to recover accidentally deleted data during that window. This feature provides protection against data loss due to unintended deletions. How can you implement automatic data tiering for Azure Blob Storage using Azure Data Factory and Manage Data Disk capability? Azure Data Factory can be used to implement automatic data tiering by extracting data from one Azure Blob Storage tier and loading it into another tier. Manage Data Disk capability allows you to manage and optimize the storage resources efficiently. Explain how Azure Storage's Storage Analytics feature can be used to monitor and audit storage activities. Storage Analytics provides insights into storage activities, including metrics and logging. You can use it to monitor ingress and egress patterns, analyze access trends, and audit storage-related events for compliance purposes. How can you ensure data availability and low latency for Azure virtual machines by attaching managed disks from Azure Storage? By attaching managed disks to Azure virtual machines, you ensure that the virtual machine's data is stored in Azure Storage and is highly available and durable. Managed disks also provide features like snapshots and disk scaling. Explain how to implement a content delivery system using Azure Blob Storage and Azure Content Delivery Network (CDN). You can store content, such as images or videos, in Azure Blob Storage and configure Azure Content Delivery Network (CDN) to distribute the content to edge locations. This reduces latency and improves end users' experience when accessing the content. How can you ensure data durability and availability for Azure Virtual Machine Disks using Zone Redundant Storage (ZRS)? By using Zone Redundant Storage (ZRS), you ensure that virtual machine disks are replicated across availability zones. In the event of a zone failure, the replicated copy remains accessible from another zone, ensuring data durability and availability. Explain how to implement automatic deletion of expired data in Azure Table Storage using Time to Live (TTL). Azure Table Storage's Time to Live (TTL) feature allows you to set an expiration time for data in a table. Once the TTL expires, the data is automatically deleted, enabling you to implement automatic data retention and cleanup. How can you optimize performance for Azure Blob storage when reading and writing large files using Azure Data Lake Storage Gen 2? Azure Data Lake Storage Gen 2 provides optimized performance for reading and writing large files. By leveraging its parallelized access patterns, you can improve data transfer speeds and optimize performance for data-intensive workloads. Explain how Azure Blob Storage's Premium Performance tier differs from the Standard Performance tier. The Premium Performance tier offers higher performance and lower latency compared to the Standard tier. It is suitable for workloads that require high FPS and throughput, such as database workloads or virtual machine disks. How can you implement data backup and recovery using Azure Blob Storage's Soft Delete and Snapshot features? By enabling Soft Delete, you retain deleted blobs for a specified retention period. Additionally, you can create snapshots of blobs capturing their state at a specific point in time. These features help in data recovery and versioning. Explain how Azure DataBox and Azure DataBox Disk can be used for offline data transfer to Azure Storage. Azure DataBox and Azure DataBox Disk are physical appliances that allow you to transfer large amounts of data offline. You load your data onto the device, ship it to Microsoft, and the data is ingested into your Azure Storage account. How can you enable secure access to Azure Storage resources using Shared Access Signature (SAS) tokens without exposing account keys? Shared Access Signatures (SAS) tokens allow you to delegate access to Azure Storage resources without sharing account keys. By defining permissions, constraints, and an expiry time, you provide temporary access to authorized entities. Explain the purpose of Blob Snapshot in Azure Blob Storage and how it can be used for data versioning. A blob snapshot is a read-only version of a blob that captures its state at a specific point in time. It can be used for data versioning, enabling you to restore previous versions of a blob if needed. How can you secure data access to Azure Storage resources from a virtual network using Virtual Network Service Endpoints? Virtual Network Service Endpoints allow you to secure data access by extending your virtual network's private address space to Azure Storage services. This ensures that traffic between your virtual network and storage resources remains within the Microsoft network. Explain how Azure Blob Storage's tiering feature can be used for cost optimization. Azure Blob Storage's tiering feature allows you to transition data between access tiers based on usage patterns. By moving infrequently accessed data to lower-cost tiers like Cool or Archive, you optimize storage costs while maintaining accessibility. How can you implement data synchronization between on-premises environments and Azure Blob Storage using Azure File Sync? Azure File Sync allows you to synchronize on-premises file servers with Azure Blob Storage. It keeps both environments in sync, providing efficient data sharing and access while maintaining data availability. Explain how Azure Storage's Shared Access Signatures (SAS) can be used for temporary access delegation to blobs. Shared Access Signatures (SAS) allow you to grant limited and temporary access to specific blobs or containers. By generating SAS tokens with specified permissions and constraints, you control access to resources without How can you secure data access to Azure Storage resources from public networks using firewalls and virtual networks settings? Firewalls and virtual networks settings in Azure Storage allow you to define IP address ranges that are allowed to access your storage resources. This ensures that only authorized networks can access your storage, enhancing security. Explain how to implement data archiving using Azure Blob Storage's archive, access tier, and lifecycle management policies. You can implement data archiving by configuring Azure Blob Storage's lifecycle management policies to transition data to the archive, access tier based on defined rules. This tier offers lower-cost storage for infrequently accessed data. How can you ensure secure access to Azure Storage resources from applications hosted in Azure Kubernetes Service (AKS) using Azure Managed Identities? Azure Managed Identities can be assigned to applications running in Azure Kubernetes Service (AKS). By configuring the managed identity to have appropriate permissions, you enable secure and seamless access to Azure Storage resources without exposing credentials. Explain how to use Azure Blob Storage's CORS, cross-origin resource sharing configuration to enable web applications to access storage resources. CORS settings in Azure Blob Storage allow you to specify which domains are allowed to make cross-origin requests to your storage resources. By configuring CORS rules, you enable web applications hosted on specific domains to access your storage securely. How can you optimize performance for reading and writing data to Azure Blob Storage using parallelism and asynchronous operations? You can optimize performance by using parallelism and asynchronous operations. For example, when reading or writing multiple blobs, you can perform these operations in parallel, allowing for efficient use of network bandwidth and faster data transfers.
Hey, if you like the content, please subscribe to my channel. Don't forget to ring the notification bell so you never miss a bite of Azure brilliance.